Hey Classroom 9, this is Ms. S, and we're going to continue talking about Jupiter today. So let's go ahead and just get right into the video and the article. So here we go. Wrong one. There it is.
The Juno spacecraft will encounter some of the most intense radiation in the solar system. So how do we protect it? Jupiter has a very strong magnetic field, 14 times stronger than the Earth's magnetic field. It's as though if we cut the planet in half, we'd find a giant magnet inside, like this one. You see, here's the magnetic field pattern created by these little pieces of iron. But Jupiter doesn't have a magnet inside. Instead, it probably has a core made of hydrogen, squeezed down to such high pressure that it acts like a metal. And when it churns and swirls, it produces this super strong magnetic field that draws particles from the sun at such high speeds that they produce the radiation equivalent of 100 million X-rays. Now that radiation would destroy the electronics on board the Juno spacecraft. So what we do is we enclose Juno's electronics in a metal vault like this one, so our electronics can survive. Now, the real vault on board Juno doesn't look like a cookie tin. It looks more like this. And it's made of titanium, like this. Very lightweight and strong metal.
Alrighty. So, moving over to the article. Get it so you guys can see the screen. Here we go. So this is called Hello from Jupiter. So what we're reading about today is the Juno spacecraft that orbits Jupiter that gives us some more information about it. So, let me zoom in. It says, on July 4th, NASA scientists nervously gathered in a mission control room in Pasadena, California. They were waiting to find out if a spacecraft called Juno had reached Jupiter. At 8:53 p.m. Pacific time, the scientists received a series of beeps. The control room erupted with cheers. The signal broadcast by Juno meant the spacecraft had made it. We only had one chance to get it right, says Stephen Levin, Juno's project scientist. So I was really relieved when Juno arrived safely. Juno's epic trip began 5 years ago when it launched from Cape Canaveral, Florida on August 5, 2011. Since then, it has traveled 2.9 billion kilometers, or 1.8 billion miles. The spacecraft is now in orbit, or following a curved path around Jupiter. Juno will get closer to the planet than any other spacecraft in history. Its mission is to gather data that could answer some big questions about the massive and mysterious planet. So if you look, this down here is Juno's journey. So it's the orbit, these orange dotted lines. So Juno launched from here in 2011, and then about 5 years later, reached Jupiter in 2016. And if you look, the key here says that from dot to dot on the orange line is every month. So you can see every month it kind of got closer and closer and closer. And it went around in that little orbit-like circle. Alrighty, extreme planet. Jupiter is the 5th planet from the Sun and the largest planet in our solar system. It's so big that 1,000 Earths could fit inside it. Jupiter, Saturn, Neptune, and Uranus are our solar system's 4 gas planets, or gas giants, which are planets made of mostly hydrogen and helium gases. Red, brown, yellow, and white clouds cover Jupiter's surface in bands, making Jupiter look striped. Winds gust across the planet at 640 kilometers or 400 miles per hour, twice as strong as the Earth's powerful hurricane, or the most powerful hurricanes on Earth. Oh no. There we go. These winds create one of Jupiter's most famous. I don't know why I did that. Okay, we'll just ignore it. These winds created one of Jupiter's most famous features, the Great Red Spot. This giant storm is about twice the width of Earth, and we talked about that in Monday's lesson when we read about the article. I think it's Hello Jupiter. Everything about Jupiter is bigger and more extreme than other planets, says Levin. It's surrounded by intense storms, and traveling into its clouds would be deadly. Scientists have learned about many of Jupiter's features thanks to 7 spacecraft that have flown by the planet and 1 that has orbited it. But Juno will get much closer than any of these past missions, which weren't designed to survive the dangerous conditions surrounding Jupiter. Built to last. The biggest obstacle to getting close to Jupiter is the intense radiation around it. The radiation comes from tiny charged particles emitted by the Sun and Io, one of Jupiter's 67 moons, and caught in Jupiter's magnetic field. Jupiter's field is much stronger than similar force on Earth that moves compass needles. It accelerates the particles to incredible speeds. It's some of the most powerful radiation a spacecraft has ever encountered. Even though these particles don't weigh much, they carry huge amounts of energy with them. These fast-moving particles can interfere with the spacecraft's instruments or damage them permanently. Before Juno went into orbit, its star tracker was shut off to prevent interference. This device helps keep the spacecraft on course. Without it, the spacecraft was flying blind. At that point, you just hold your breath and cross your fingers, says NASA astrophysicist Jack Connerly. Juno was so far away that it took 48 nail-biting minutes for its communications to reach scientists and let them know that the spacecraft had arrived. Scientists still have to worry about radiation as Juno orbits Jupiter to help protect I'm not sure what's up with Scholastic today. It doesn't normally do this to me. To help protect, the spacecraft engineers designed Juno to follow an orbit that dips in and out of Jupiter's radiation belt. That way, Juno can avoid the most intense patches of charged particles and limit the damage that they are expected to cause. On this oval-shaped path, Juno soars from Jupiter's north to south pole. As Jupiter rotates, Juno will get close up and look at the different parts of the planet. With each flyby, it can snap amazingly detailed pictures and capture valuable data. Gathering data. To further protect Juno, engineers put its electronic components inside a vault about the size of an SUV's trunk. It's made of the element titanium, a light but extremely strong metal. Juno's onboard instruments are crucial to the mission. They will allow the spacecraft to peer below Jupiter's clouds and reveal the materials churning deep inside the planet. One instrument, for example, called a microwave radiometer, is measuring how much water is in Jupiter's atmosphere. Another tool, called the magnetometer, magnetometer, will measure the magnetic field around and within Jupiter. It can help scientists learn about Jupiter's interior, where an ocean of liquid metal hydrogen lies above the planet's core. Scientists believe that this ocean helps create Jupiter's magnetic field. Information about Jupiter's composition could help explain how the planet and the rest of our solar system is formed. About 4.6 billion years ago, what would become our solar system was just a spinning cloud of gas and dust. 99% of the material in the cloud became the sun. Jupiter was the next to form, taking more than 2/3 of the leftover material. All the other planets, including Earth, formed from what remained. Understanding how Jupiter was formed will help us understand how Earth and everything on it came to be, says Levin. Mission ahead. Juno will orbit Jupiter for at least 37 times, collecting data to relay back to Earth. Eventually, the radiation surrounding Jupiter will take its toll on the spacecraft. Experts expect that Juno will have to end the mission sometime in 2018. When that happens, the spacecraft will be sent on a controlled dive into the planet's stormy clouds and burn up like a meteor. Until then, Juno has a lot of work to do. Its cameras, which NASA scientists powered up again once Juno was past the most intense radiation, have already snapped spectacular close-ups of Jupiter. NASA scientists eagerly await new discoveries made by the spacecraft. We're expecting all kinds of surprises, says Levin. And then below you can see, and you may want to just kind of look at this picture because your Google form may or may not be based on these 4 parts of this organizer here. Just a hint. It says dangerous radiation. Strong bands of radiation surround Jupiter. They are created by the planet's immersed magnetic field, which traps fast-moving charged particles from its volcanically active moon to and from space. So the first part is the radiation belts, which is here. And they energize the particles trapped here, move at nearly the speed of light. That's about 3 million meters or 9,800,000 feet per second. The problem particles, the radiation from these high energy particles can damage a spacecraft's instrument and interfere with how they function. Then we have over here the safety precautions. A metal vault shields most of Juno's instruments from radiation. Juno's orbit avoids the most intense radiation around Jupiter. Because again, radiation is going to destroy this spacecraft. So they wanted to avoid that for as long as possible. And then the magnetic field is more than 4.8 million kilometers wide. So that's 3 million miles. And it's about 20,000 times stronger than Earth's magnetic field. So again, you guys are going to use this chart. If you even look on here, right under your name, I copy and pasted the chart here for you to answer the 4 questions for the Google form. Other than that, I don't have anything else for today. After you watch this video, we are actually going to be moving on in the month of May to science current events. So I just kind of found some random articles that I thought would be interesting. Our first one's going to be about the coronavirus, and then we're going to kind of move on to just some kind of random science stuff. So hopefully you guys enjoy that. I will see you in the next video. Have a fantabulous day, Classroom 9, and catch you guys later. Bye.